Section 11.8 is all about combinations. A combination is a distinct group or set of objects without regard to their arrangement. So this is what makes it different than a permutation. In a permutation, the order matters, like president, vice president, secretary. In a combination, the order does not matter. So board members, nobody's ranked ahead of anyone else. The combination formula. So the number of combinations possible when R objects are selected from N objects is found by the combination formula. It's going to look like NCR on the paper. In the numerator, you're going to have N factorial, and in the denominator, you'll have two items. You'll have N minus R factorial times R factorial. Let's look at a situation with this formula, and I'll show you how to also complete this problem with your calculator. In your American history class, you are assigned to read any 3 books from a list of 8 books. In how many ways can you select 3 of the 8 books to read? So again, in this situation, order does not matter. Your teacher does not care what order you read the books. You just need to read 3 of the 8. So you would say that you have a set of 8, and you would like to do a combination of 3 of them. So the formula says that you should do 8 factorial in the numerator. In the denominator, you should do 8 minus 3, which is 5 factorial, times 3 factorial. So if you're doing this by hand, you could write it out. 8, 7, 6, 5, 4, 3, 2, 1. And then 5 factorial would be 5, 4, 3, 2, 1. And 3 factorial would be 3, 2, 1. So if you wanted, you could start eliminating. We have a 5, 4, 3, 2, 1 in the top and a 5, 4, 3, 2, 1 in the bottom. Dividing by 1 isn't going to do anything. And 3 times 2 is equal to 6. So the 3 times 2 in the bottom can eliminate the 6 on the top. And you'd have 8 times 7. There are 56 different possible ways that you could select 3 out of 8 books. Now, if you were going to do this on your calculator, you're going to find it in the same general area that you did the permutation. So I'm going to turn my calculator on. I am going to first type in the 8, because I have 8 books I want to read. I'm going to hit the math button. I'm going to scroll over to probability. And I'm going to select option number 3 for the combination. And then I will say I want to select 3 of 8 books, and I will be given the 56. So notice when order does not matter, there's a lot less possible ways that you can have the combination made. Let's try another one. Jan has 10 different photos from which she will choose 6 to hang on a wall. How many different ways can she do so? So order is not going to matter. Order is not going to matter. The photos are not ranked in any way, so it doesn't matter that the Hawaiian photo is on the left. That doesn't matter. You just want to know how many different ways she can select to hang. So this is a combination. She has 10 photos, and she's going to select 6. So the formula says I need to do 10 factorial in the numerator. And in the denominator, I need to do 10 minus 6, which is 4 factorial, and 6 factorial. So if you wanted to write that all out, your numerator would be 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. 4 factorial would be 4, 3, 2, 1. And 6 factorial would be 6, 5, 4, 3, 2, 1. So you can start eliminating the 6, 5, 4, 3, 2, 1 from both the top and the bottom. You can also eliminate the 1 in the bottom. That does nothing. 4 times 2 is 8, so you could eliminate the 8 in the top. And 3 goes into 9 3 times. So if you want, in your numerator, you can take 10 times 3, which is 30, and 30 times 7, which is 210. Most people are just going to prefer to use their calculator, so let's review that one more time. I am first going to type in the 10 since I have 10 photos. math, probability, combination, six. And you'll get the 210 that way. All right, last example. At the Oriental Cafe Chinese restaurant, dinner consists of selecting 3 items from column A, 4 items from column B, 3 items from column C. Columns A, B, and C have 5, 7, and 6 items respectively. How many different dinner combinations are possible? So keep in mind when you have multiple activities going on that you are going to multiply the 3 events. So we have to figure out what's going on with column A times column B times column C. All right, so let's look at column A first. We are supposed to select 3 items from column A, and column A has 5 items in it. Now again, the order does not matter here, so this is a combination problem. So we need to do 5 combination 3, and that's going to tell us what's happening in column A. Column B, we are supposed to select 4 items from column B, and column B has 7 items in it. So we'll do 7 combination 4, and that'll tell us all the possible ways to select from column B. Then we have column C. In column C, we are supposed to select 3 items, and it has 6 in its column. So we'll need to do 6 combination 3, and that'll tell us what's happening with column C. So me personally, I would probably find the value of each separately in my calculator. So I'd go to my calculator and I would figure out 5 combination 3. That should give me a value of 10. And then I'd go to my calculator and do 7 combination 4, which is going to give me 35. And I'd go to my calculator and do 6 combination 3, which is going to give me 20. Then you have to multiply all 3 of these together. 10 times 35 is 350. 350 times 20 is 7,000. So there are 7,000 different ways you can order from this restaurant.